wanted to introduce a travel size guitar to the market, and it started with dimensions, really, right? We wanted to know how big we wanted the upper bout, how big we wanted the lower bout, the depth at the neck block and the tail block. Once we had come up with our ideal dimensions, we started to build this thing three-dimensionally in a digital form so we can visualize it before we actually build the thing. Then we start engineering the different parts of it. So we have to build programs to cut our tops and our rosette cavities, build different programs to do the neck barrel carve, which is back here. Obviously do engineering for the fretboard programs as well. So once we made all those parts, we were ready to get the ball rolling in terms of building one. And we start by, like I said, cutting that top, cutting the back, and then we get into our sides, right? Those sides have to taper perfectly to match up with that dimension of the tail block, the dimension of the head block. So we build fixtures for that we're able to build to the exact shape on our shaper. We also had to build the molds for what we do with the sides and the other pieces once we're done with that. So after we have blocked the thing up with its head and tail block, the thing is set in there really well. We've already built the top and back plate. Now we're ready to do some bracing. So that was the next step of our process into how to develop this thing. The way we came up with how to do this, a lot of it has to do with sound optimization. So that starts with raw wood, where we're deciding what thickness the top should be and how heavy the back should be, because we do our tops by a target thickness and our backs by a target weight. But then we get into the braces, and a couple things we found out, and we use sound optimization to figure this stuff out in terms of the bracing pattern and the bracing profiles. So what I mean by that is the bracing pattern is how all those braces look on the inside of the guitar, and the profiles is their actual shape. So one thing we figured out after a few cracks at it is that we wanted to change some of the back braces. We were using 5/8 braces on the bottom of the ladder and wanted to switch that up to 3/8 to match all the way through and make that back more flexible. So that was one of the changes we made as we started building these. Same with the top bracing. We use scallop braces in the X brace. That's where most of our frequency changes come in sound optimization. So we knew we wanted to increase the depth of those scallops because we started with the closest body shape that we were already building, which is the concertina, and we moved from those braces a little down. And at the end of the day, we got this guy here. Now this is the non-cutaway version. The version that's gonna be hitting the marketplace is a cutaway. This is just where we started. We were all really happy with the final product. Still a couple little tweaks we're gonna make, but nothing major. We figured most of that stuff out throughout the build. This thing, when we tested it at the very end, so final inspection sound optimization test hit the exact numbers we were looking for. So all the little changes that we made throughout the build ended up making a great final product. And the real nice thing about this small guitar is not only its convenience factor, but the fact that you're not compromising on sound. You can record with it, you can jam with it, you can play on stage with it. I mean, it can do everything the rest of our guitars do just as well.